Hi, everyone, and welcome back. It's Kira Garfola with Greenville Tech's Math 109. Today, we'll be talking about section 2.3, which is systems of linear equations in two variables. So what are systems of equations? A system of equations is just a collection of linear equations that all have to be true. So if we have a solution to that system, it's a combination of variable values that make all the equations true. Now, the start of this section is called in two variables, and that is going to be x and y most of the time in our cases. Now, remember, x and y are just placeholders. It could be t and v, it could be x and z, and so on, but you're just dealing with two variables. A solution will be an x value and a y value, or multiple x values and multiple y values in the case of nonlinear. We can solve these systems graphically or algebraically. Let's start with a graphical approach. So the simplest approach, at least in my opinion, is to use our calculator's intersect feature. We've done this in a previous section, but now we're going to be applying it to systems of equations. What you'll do is you'll set one of your equations to y1 and one of your equations to y2 in your calculator. You'll graph it. You'll use the window that will show where those two lines intersect. And when you use the intersect feature, it'll tell you the exact coordinates of where they meet. That will be your x and your y solutions. Let's do an example. Let's solve this system using the intersection method. Now remember here that the first thing we need to do, since we're entering it into the calculator as y1 and y2, is we need to solve for y in both of these systems, or in both of these equations, excuse me. So we want to solve for y first. We can also use the x-intercept method if we prefer, by moving everything over to one side. Okay, so before I show you those results, let's actually work on this. Let's do the whiteboard first. One day I'll learn where everything is in Zoom. They keep changing it on us. So if we look back here, we had 3x plus 4y equals 10. So 3x plus 4y equals 10. Three x plus 4y equals 10. To solve this one for y, we can move the 3x over to get 4y equals 10 minus 3x. And we solve for y by dividing by 4. So y equals 10 over 4 minus 3 over 4 times x. Now we can notice that 10 over 4 is the same as saying 5 over 2 minus 3 over 4x. That would be unnecessary if you're typing it into the calculator because it's smart enough to do that for us. Now, if we go back and look here at the PowerPoint, we see that the other equation is 4x minus 2y equals 6. So 4x minus 2y equals 6. And we want to solve for y again. So I would put the 2y on the other side. I would have 4x minus 6 equals 2y, and divide by 2 would give us 2x minus 3 equals y. So we're going to put this in for one y and this in for another y into our calculator. So let's see here. We get a y equals and we had 5 halves minus 3/4. So 5 halves minus 3/4 x, and the other one is 2x minus 3. And when we hit graph, we see one line, and then we see the other line. So we can see that these intersect right around here. I apologize if this wasn't showing my whole screen. Let's try that again. Once we solved for y, we wanted to go ahead and put y equals 5/2 minus 3/4 x and 2x minus 3, just like we solved on the whiteboard. And when we hit graph, it's going to draw those lines for us. Now, sometimes it takes the lines a minute to draw, especially if it's a real complex equation. So just be patient with your calculator if you need to. Now we're going to use our intersect feature. So since we want a graph feature, we're going to go to second, calc, and we want where these lines intersect. So we want option 5. Our first curve is already highlighted for us. We press enter. Our second curve, we need to make sure it's on that other curve. It is. We press enter. And we want to make it guess. Usually, as long as that intersection is on this screen, we're good, but you can always scroll near it and press enter. And it's going to think for a second. And now it says, hey, your intersection is at x equals 2 and y equals 1. So that is the solution. We can put it as a coordinate as 2, 1 for our solution. Okay, now if we go back over here, make sure the screen is showing, we can see that we did end up with this system, indeed, 5/2 minus 3/4 x and 2x minus 3. And when we graphed it, here's one line, here's the other line. That intersection, just like we found, is at x equals 2 and y equals 1. So we can write our solution as that ordered pair of 2, 1. Now take a few moments to pause this and make sure that you can solve the exact same way and get the same solution. When you're ready to move on, you can just hit play again. Now there are a couple of different ways to solve this algebraically too, if we don't want to just work graphically. Often the easiest way is problem dependent. So sometimes substitution is going to be easier, and sometimes the other method that we're going to talk about called elimination is also easier. Sometimes it's a personal preference. Sometimes graphical is easier. Really, unless you're told which way to solve this, you're free to use whatever you want. Also, don't forget that you can check your answer using another way, even if you're told to use a way that you don't prefer. So when we're doing substitution, we're going to solve one of the equations for one of the variables. You can use either equation, you can use either variable. So solve for x or solve for y using either of those equations you're given. You're going to substitute that value into the other equation and solve for the other variable. And then you're going to go back and plug that back in and solve for the remaining unknown value. Now that sounds like a nightmare, but I promise you it sounds more confusing than it actually is. So let's see it in play with a real example. So let's use our earlier system, and we're going to solve by substitution on the whiteboard. So remember, we had 3x plus 4y equals 10 and 4x minus 2y equals 6. So I'm going to take us back to the whiteboard. And I am going to erase everything. I'm actually just going to clear it, I think. Okay. So we had 3x plus 4y equals 10. And we also had 4x minus 2y equals 6. Now, I look at this and I'm just going to say, okay, I'm going to solve this one for y. You could really use any of them for either variable, but I think that's going to be easy. I'm going to solve this for y. We did this a minute ago. I'm going to have 4x minus 6 equals 2y. So that's going to give us 2x minus 3 equals y. That's our first step. Now we go back and use this other equation to plug that in. So now we go up here and say, cool, 3x plus 4, and remember this is y now. So times 4 times 2x minus 3 equals 10. Now we use basic algebra to solve for x. So we know that 3x plus 8x minus 12 equals 10, which is going to tell us that 11x equals 22. So x has to equal 2. So there's one of our solutions. And then we can go back and plug x equals 2 into either of the equations to solve. So 4 times 2 minus 2y equals 6 gives us 8 minus 2y equals 6, which is going to give us y equals 1. I skipped a couple of steps algebraically there, so make sure that you can solve that using basic algebra for y equals 1. So now we see that x equals 2 and y equals 1, which we can also write as 2, 1 as before. Again, take a few moments, make sure that you can solve this. And I've saved a solution here for you so that you have it for later reference if you don't have time to watch the whole video again. There's another method we can use called elimination. And elimination is a little bit tricky for some people, but in a lot of problems is a lot easier than using substitution or graphs. So what you're going to want to do is add or subtract multiples of the equations to basically cancel one of your variables out. Then you're going to solve what's left for that remaining variable. And just like in substitution, you'll then go back and plug that in to solve for the remaining unknown. So let's look at an example. So first, suppose a fast food restaurant has 2 combos. In combo A, it has 2 burgers and an order of fries, and combo B has 1 burger and 1 order of fries. You want to make sure that you order 26 burgers and 16 orders of fries. So first we need to write the systems of equations that represents the problem, and then we'll solve. So let's let x be the number of combo A and y be the number of combo B. So we want to know how many x's we need to get 26 burgers and how many y's we need to get 16 fries. Let's first start by writing our burgers equation. So we know that combo A has 2 burgers and combo B has 1 burger. So we want however many A that we have plus however many B that we have to equal 26. So 2 times x plus y, so 2 times the number of A combos plus 1 times the number of B combos needs to equal 26. Similarly, we can do the same thing for fries. Each one only has 1 order of fries, and we want to have 16 total orders of fries. So we know that the number of A plus the number of B should equal 16, or x plus y should equal 16. Now we can solve this using any method that we'd like. I'm going to use elimination since that's what we've been working on. So 2x plus y is 26 and x plus y is 16. We know that 2x plus y equals 26 and x plus y equals 16. Now, since we have 1x and 1y here, I think it's easier to just subtract one from the other. So let's subtract this one. If we subtract this, we're going to get 2x minus x is going to leave us with 1x. Y minus y is going to cancel out and be 0. So x plus 0 equals 26 minus 16 is going to give us 10. So here we know that x equals 10. We're halfway there in our solution. So then we can go back and plug it into either equation. We also know that x plus y equals 16. So that tells us that 10 plus y has to equal 16, which means that y has to equal 6. Now you can take a minute and make sure that you solve it the other way, and you'll see that y equals 6 also. 2x plus y would be 2 times 10, so 20 plus y equals 26, and that would also give us y equals 6. So our solution is 10, 6, or 10 combos A and 6 combos of B. If we look at the slide, we just solved that in the whiteboard, and here is our solution. Again, it's just a copy of what I just showed you, but it's there for easy reference. Now, suppose we wanted to check that graphically. If the problem hadn't told you to solve by elimination, or maybe you just want to double check your work, you could graph y equals 26 minus 2x and y equals 16 minus x. Remember, you have to solve each one for y first, and you would get these two lines. If you use that intersect tool, you'd see that x equals 10 and y equals 6, which is exactly what we just found. This is excellent practice for the graphical solution, so I would highly encourage you to pause this, make sure you can solve this with elimination, and make sure that you can solve this graphically. If you'd like, this is also an easy one to solve with substitution. So it's a good way to get lots of practice. Any of the ways will give you the exact same solution as long as you don't make any mistakes. Now, there are a couple of special cases of systems. Sometimes what you'll end up with, instead of getting x equals 2 or x equals 10, you're going to end up with just a numerical statement that is always going to be true. Sometimes you'll end up with something like 0 equals 0. Well, obviously, because 0 is always equal to 0. In this case, there are infinitely many solutions. So as long as your x and y solve one of them, it will solve both of them. Now be careful here. That doesn't mean that any XY pair that you can possibly dream up is necessarily a solution. It just means that any solution to the first one is also a solution to the second one. Graphically, what we'll see is they're actually representing the same line. This is called a dependent system. Let's look at an example here. We're going to solve the system 3x minus 2y equals 5 and 9x minus 6y equals 15. So let's move back to the whiteboard. And I'm going to write 3x minus 2y equals 5 and 9x minus 6y equals 15. Now, if I look at this, there are several different ways to solve this. I personally think that it's going to be easier to solve this with using the method of elimination. So feel free to use any method you wish. Again, it's going to be easiest if you, it'll be easiest using the method you prefer, but as long as you get it correct, you'll be fine. Don't do this one graphically though. If you're going to pause and solve this and see if you can get it on your own, use substitution or use elimination. I want you to practice with those. Okay, I'm going to use elimination, okay? I am going to use 3 times this. I'm going to use 3 times 3x minus 2y equals 5. And I am going to subtract the first one. So minus 9x minus 6y equals 15. So this is going to give me 9x minus 6y equals 15. And then the bottom will be negative 9x plus 6y equals negative 15. Now, if I add these together, I notice here that 9x minus 9x is 0. Negative 6y plus 6y is 0. And 15 minus 15 is 0. So I end up with a statement 0 equals 0, which is always going to be true. So that means that this is going to be a dependent system. It doesn't have to come out to be 0 equals 0 either. That's an important note to make. It could come out to be something like 1 equals 1 or 22 equals 22. As long as it's an always true number equals number situation, you're going to end up with a dependent system. And here is some of the work. On this work that I snapshotted, instead of doing 3 and then minus, I just multiplied everything in the top times negative 3. Again, multiple ways, effectively did the same thing. No matter how you did this, even if you use substitution, you should come up with a dependent system. Now, if we can have those cases where a number equals a number all of the time, then it should make sense that we could end up with something that doesn't make any mathematical sense. If you end up with an equation that is never true, there's no solution, and you end up with what is called an inconsistent system. So this could happen with parallel lines, right? They are never, ever, ever going to touch. And so if they don't ever intersect, you can't ever solve them. An inconsistent system is going to give you something like, oh, 0 equals 2 or 3 equals 1, something that you know isn't equal, so it's not possible, leading you to know that there's no solution. Let's solve this system. I'm going to move us to the whiteboard again. I'm going to clear it if my mouse will work. I'm going to have negative 3x plus 5y equals 8 and 6x minus 10y equals 12. If I use this, I am going to actually try elimination again. I'm going to do 2 times the top, so 2 times negative 3x plus 5y equals 8. And I'm just going to add it to the original 6x minus 10y equals 12. So doing this, I'd get negative 6x plus 10y equals 16. And on the bottom, I have 6x minus 10y equals 12. Now, when I add those up, I get negative 6x plus 6x is going to give me 0. I get 10y minus 10y, so I get 0. And I get 16 plus 12, which is 28. I end up with 0 equals 28. We know that this is never true, because 0 can only equal 0 and 28 can only equal 28. So we know that we have an inconsistent system. In other words, there is no solution to this system. So wrapping up this section, remember there's often going to be several appropriate approaches. You can use, unless it's specified on a test, you are welcome to use whatever method you prefer to solve this. Please go back and practice, practice, practice. Remember, you have unlimited attempts on homework, unlimited attempts on quizzes. And so you're going to want to get practice doing those. Before you even attempt those, I would make sure that you can pause this video or go through the slides that I've provided and make sure that without looking at my solutions, you can get the exact same solutions as well. Remember that there are all kinds of additional resources, including other videos and notes and publisher resources in our Blackboard folder. Remember, the Math Center is always here to help, including their review sessions for 109 and my office hours and email if you need additional help. Have a great day, and I will see you next time.